Hello, my name is Michael Hostetler, and I'm going to be teaching y'all Calc 2250 and the definition of derivatives. The definition of the derivative is dy over dx is equal to the limit of h going to 0 of f parentheses x plus h parentheses minus f of x over h. Now the problem we're going to be using this definition on is 3x squared plus 5x. Now the way we start this problem is we enter this into the definition, and the way we do that is enter where everywhere we see an x is that's where we're going to enter an x plus h in the beginning, and then we're going to minus the whole function here. So the way we start is 3 parentheses x plus h parentheses squared plus 5 parentheses x plus h parentheses minus the original equation, which this is equal to f of x. So minus f of x, which is 3x squared plus 5x. And that's in parentheses. That's very important later. All divided by h is going to the limit of h to 0. So first we want to, we're going to isolate the numerator, and we're going to distribute these terms all throughout. So first we're going to work on this term. We're going to do that over here. It's going to be, first we're just going to focus on the squared part. So we're going to go x plus h parentheses x plus h parentheses. Now if we really want to make it written out, we're going to go like that. But first we're going to work with the x plus h and x plus h. So the way we distribute this out is FOIL, which is the x times x times h times x, and h times h. So first we're going to do x times x, which is x squared. We're just going to drop 3 down for right now. And then next we're going to have x times h, so plus xh, and then x times h, well h times x, sorry, plus xh, and then h times h, which is h squared. So then we have the 3 and all of this. First we want to combine this, so we're going to drop the 3 one more time. X squared plus 2xh plus h squared. So then now that we have this, we can distribute the 3 to all of these terms. So first we're going to go 3x squared plus 6xh plus 3h squared. Now this is important. We're going to use this later. Next, we are going to use the 5x plus h. Now our step is to distribute the 5 to the x and the h. We'll start that over here below that. So we'll have 5 parentheses x plus h. So then we're going to go 5x plus 5h. And then now we're ready to rewrite our fraction here, our limit, with these now distributed numerator terms. So now we're going to write it 3x squared plus 6xh plus 3h squared plus 5x plus 5h minus parentheses 3x squared plus 5x all over h. See, now we can, we need to distribute this negative sign out to these two terms. So we'll do that over here. 3x squared plus 5x, parentheses, you have the negative sign, so that's going to be negative 3x squared minus 5x. So we'll rewrite this whole thing again. 3x squared plus 6xh plus 3h squared plus 5x plus 5h minus 3x squared minus 5x all over h. So now what we have to do is combine like terms. So we're going to combine like terms in the numerator. So the 3x squared right here are both going to cancel out since this one's negative and this one's positive. So those are canceling out. And then we have 5x and negative 5x. So those are going to cancel out. And now all we have left is a new numerator of 6xh plus 3h squared plus 5h. Now, we have that all over h, and this limit just keeps distributing down, so this is equal to the limit of h going to 0. Now, what we're going to do is divide all of these terms by h. So the h is going to cancel here. This h is going to cancel one of the two h's that are here in the exponent, so that makes this just h. And the h here is going to cancel this h out in the 5. So all we have is the limit of h going to 0 is equal to 6x plus 3h plus 5. Now is equal to dy over dx. Now to determine dy dx in the official derivative, we have to plug in 0 everywhere we see an h. So in this scenario, dy over dx is going to be equal to 6x plus 5, because when we plug in a 0 right here for 3h, that's going to be 0 because 3 times 0 is 0. So our final answer is dy dx is equal to 6x plus 5. Thank you. Does anybody have any questions, or do you need me to go over the problem again?